The teaching at Vedantu was amazing. One aspect where Vedantu teaching differed from a normal offline coaching was the attention teachers gave to our doubts. No matter how many times we asked a doubt, the teachers would patiently clear the doubt every single time. And they made learning a very fantastic experience for us.
Hi guys, this is Saurav here and welcome to another session of Chemical Kinetics. This is for grade 12th and this is the third lecture, and in this lecture we will try to cover zero order reaction. Hello Preetham, hello Anit, hello Ajay, hello Anurag, and welcome everybody to this session. And in the previous session what we had done was हमने क्या क्या cover कर लिया था. We had covered rate law. Hello Navneet, hello Sketcher, hello Shali. And we had covered rate law, we had covered order, we had covered molecularity. We were trying to cover, we did discuss that what is the meaning of order, what is the meaning of molecularity, when would they be alike, when would they not be alike, and on the basis of that, what inferences we can draw. Okay, so let's start today's session. But before that, please do like, share and subscribe as I tell you in every class. And if you look at the completion, the extent of completion, we have completed rate law, we have completed order and molecularity. Today we would start with zero order reaction, and then we'll discuss first order and nth order. First order reaction will go for a longer duration. Zero order reaction easy है, zero order reaction हम इसी class में खत्म कर लेंगे. Okay, and then after everything gets over, we'll discuss problems. So let's see what we have to do in today's class. But before that, we start today's class with an example. Okay, we start today's class with an example. Can you see this? A gas phase decomposition of nitrous oxide N2O is represented by an overall reaction which looks like this. Okay, the overall reaction looks like this. Ignore this plus. Step 1 of the reaction is this, step 2 of the reaction is this. You have to identify the molecularity of each of the elementary reactions. Like a step 1 is an elementary reaction, that because it takes place in a single step. Step 2 is an elementary reaction because it also takes place in a single step. And also write the respective rate laws. We have to write the respective rate laws. How do you write the respective rate laws for each and every step? How do I write that? So what is the molecularity for the first one? What is the numerical prefix that you can see over here? 1. So the numerical prefix since is 1, so molecularity for this step is 1. So molecularity is 1 for this step. What is the molecularity for this step? The molecularity for the second step is 2. What is the overall molecularity? What is the overall molecularity? Can you please tell me what is the overall molecularity? The overall molecularity is, Ajay says 2, Preetham says 3. The overall molecularity is not defined. The overall molecularity is not defined. Molecularity cannot be 0. Molecularity has to be 1, 2, 3, at the max 4, cannot be fractional, cannot be negative. Molecularity is not defined for a multi-step process. So for an overall reaction, molecularity cannot be defined because the reaction takes place in more than one step. Okay? Is that understood? Molecularity cannot be defined for the overall reaction. Slowest step of the reaction cannot make, or what you can do is, we take the slowest step of the reaction and call it the molecularity of the reaction, but we do not know what is the slowest step of the reaction, so we cannot define the overall molecularity. Okay, so just a moment please. What happened? Let's just, okay. Molecularity of the elementary reaction, overall reaction. Also write the respective rate law. So the rate law for the first reaction would be written as rate is proportional to N2O to the power 1. For the second reaction, it will be written as rate is proportional to N2O to the power 1 and O to the power 1. Okay, O to the power 1. Now it is important to know, अगर मैंने ये question दिया है ना, if I ask you what is the intermediate in this reaction, if I ask you what is the intermediate in this reaction, then intermediate is one which gets carried forward from reaction 1 to reaction 2. What is getting carried forward? Oxygen. O is getting carried forward. So O turns out to be the intermediate. O is getting completely consumed. Intermediate is something which will get completely consumed during the course of reaction. That will not be reflected on the reactant side, not be reflected on the product side. मतलब reactant की तरफ में भी वो नहीं दिखेगा, product की तरफ में भी वो नहीं दिखेगा, ठीक है? So ये oxygen will turn out to be the intermediate. Clear? So with this, let's look at the solution. Solution, overall reaction ये होगा, intermediate is oxygen. Molecularity of each of the elementary reactions is 1 and 2 that we had identified. Molecularity of the overall reaction is not applicable or not defined. Rate law will be written as R1 proportional to N2O, R2 proportional to N2O, O. Okay, very easy question. Okay, let's take the next question. Next question is a problem. You have to solve this problem. The question is this: N2O5 changes to 2N2O5 changes to 4NO2 plus O2, and if DN2O, sorry, it has to be a small error है, ये N2O5, DN2 minus DN2O5 is equal to K1N2O5, dNO2 by dt is K2N2O5, dO2 by dt is K3N2O5. What is the relation then? What is the relation between K1, K2 and K3? Okay, what is the relation between K1, K2 and K3? So please try to solve the question. It's a very easy question, बहुत simple question है, सिर्फ mathematical manipulation करके आपको आंसर आ जाएगा. Anit says A. Anybody else? Likesh says C. बताइए. Lokesh has retracted his answers. Preetham says A. Hello Shantanu. Anurag says A. Sketcher says C. So let's see what will be the answer. कैसे हम solve करेंगे इसको? So for this reaction, can I write half minus half d N2O5 upon dt is equal to 1 by 4 d NO2 upon dt, which is equal to d O2 upon dt. लिख सकते हैं? This can be written. This can be very easily written. For this reaction, I can write this relation with the rate of decomposition of N2O5 and rate of formation of NO2. Yes? Now, it is already given in the question that minus d N2O5 by dt is K1 N2O5. So, I can write minus half K1 N2O5, which is equal to 1 upon 4 K2, sorry, this minus won't be here, K2 N2O5, which is equal to K3 N2O5. N2O5 gets cancelled. I would be having K1 by 2, which is equal to K2 by 4, which is equal to K3. Okay, now I multiply everything. I multiply everything with 4. I multiply everything with 4. I would be getting 2K1, which is equal to K2, which is equal to 4K3. The right answer should be C. Right answer should be C. Clear? The right answer should be C. ठीक है? So yeah, let's move ahead. Now let's talk about what is the general expression for rate of any reaction. The general expression for rate of any reaction will be written as rate is equal to K concentration raised to power n. Okay, it will be written like this. So let's say there is a reaction where A changes into products and it is of nth order. I do not know what the order is, so I will raise the concentration to the power n and I will remove the proportionality and put a constant K, and this constant K is known as rate constant. This constant K is known as rate constant. Now my question to you guys is rate constant affected by the constant change in concentration? If I change the concentration, will the rate constant be affected or not? Means, will the value of rate constant change if the concentration of the reactant is changed? Think carefully. The right answer is no. The right answer is no. If I increase the concentration, the rate will also proportionally increase and K will remain constant. इसीलिए so constant बोला गया है. That is the reason it is known as constant. It is constant at a particular temperature. Yes, very good, Anit. It is constant at a particular temperature. If you increase the temperature, then rate constant will change. Okay? Clear? So remember that rate is equal to rate constant times concentration raised to a power n, where n represents the order. Now, if I want to calculate the unit of rate constant, I will do a dimension analysis. Rate is written as mole per liter per second, and A will be written as mole per liter to the power n. Okay? Mole per liter per second, and concentration will be written as mole per liter to the power n. So our rate unit of K will become mole to the power 1 minus n, L to the power n minus 1, S to the power minus 1. Okay? Remember, unit of rate constant. Yeah, obviously, Preetham, I'm not saying that it will not depend on the presence of catalyst. We'll discuss properties of K when time comes, but for now, change in concentration is not going to affect the value of K. So if you do a dimension analysis, rate is moles per liter per second. Rate will always be moles per liter per second. Do not ever make this mistake. Rate will always be moles liter per second. At times, if you take gaseous substances, moles per liters की जगह atmosphere लिया जा सकता है. Okay, if you are taking gaseous substances, rather than taking moles per liter, we can take atmosphere, and it will be atmosphere second inverse. Okay, atmosphere will become the concentration. Concentration will be represented in terms of atmospheres. Okay, clear? Now, if rate is represented as mole per liter per second and concentration is moles per liter to the power n, the unit of K will become this: moles to the power 1 minus n, liter to the power n minus 1, second to the power minus 1. Now it is important to know that you might be given a question and you are not being told that what is the order of the reaction. Okay, एक क्वेश्चन दे दिया गया, उसमें बोला कि हाफ लाइफ निकालो या कुछ चीज निकालने को बोल दिया गया, and you are not being told what is the order of the reaction. How would you identify the order of the reaction? By looking at the unit of rate constant. Okay, by looking at the unit of rate constant, you can infer that what will be the order of reaction, which equation you need to use. Okay, which equation you need to use for calculating the rate constant. I need this relation, and if I have to identify what is the order, I can go in the reverse direction as well. Okay, I will go in the reverse direction as well. Clear? Obviously, Preetham. So if I look at what are the units which are possible, So if it is a zero order reaction, then this part will become 1 and unit of K will be nothing but the unit of rate. So for a zero order reaction, the unit for K will be moles per liter per second. Okay, moles per liter per second. If it is N is 1, order is 1, then it will be time inverse, second inverse, minute inverse, hour inverse. So it will be second inverse. Okay. N is 2. If it is 2, then it will be written as mole to the power minus 1, liter to the power 1, and second to the power minus 1. If it is 2.5, you can calculate it accordingly. So it is important to know that whenever you are given an unknown reaction, look for the unit of K so as to decide which equation to use to solve the question. Clear? Look for the unit of K to use an equation, because you will have 3 or more different equations to calculate different features. Clear? Yes. Yes, Gunjit, order can be negative. Yes, order can be negative, can be fractional. So what is the order if the unit of K is mole to the power minus 3.5, liter to the power 3.5, second to the power minus 1? What is the order of the reaction if unit of K is mole to the power minus 3.5, liter to the power 3.5, and second to the power minus 1? Think carefully. Sketcher is given an answer, Pankaj is given an answer. बताइए क्या आंसर होना चाहिए? So what is the general expression for calculation of K? K is equal to mole to the power 1 minus N, liter to the power N minus 1. Okay, so 1 minus N is minus 3.5, N minus 1 is 3.5. Second, the power for second is not going to change, it will not depend on the order. So N value will be equal to 4.5. N value will be equal to 4.5. Easy question, without any problem you will be able to. Prince, 4.5 hoga. It will be 4.5. Look carefully. It will be 4.5. Okay? Cool? So if anybody has a confusion, remember the unit of rate constant mole to the power 1 minus N, liter to the power N minus 1, second to the power minus 1. Clear? Chalo. Let's move ahead. Let's take this question. 4 options. Read the question, it's slightly lengthy. Consider a reaction X plus Y changing into products. If the initial concentration of X is increased to 4 times of its original value, keeping the concentration of Y constant, the rate increases 4 folds. So 4 times increase of X concentration increase the rate 4 times. When the concentration of X is kept constant and Y becomes 4 times, the rate of reaction becomes 16 times the original value. So what should be the answer? 16 times the original value. So if I increase X 4 times, the rate becomes 4 times. If I increase Y 4 times, rate becomes 16 times. Answer should be very easy. Answer B ho jana chahiye. Answer should be B. Without a doubt. Navneet, it should be B. 1-1 कैसे हो जाएगा? Okay? अच्छा, both लिखा गया. Okay, so if it is written both, then answer should be C. I'm very sorry. If it is written, it's written that concentration of both X and Y becomes 4 times. Both X and Y. Both X and Y becomes 4 times. So the answer will be C. So 4 times, it will become 16. I misread the question as only Y is being increased and X is kept constant, but The question is when the concentration of both becomes 4 times. So rate becomes 16. So power to each of them will be 1. Okay, power for each of them will be equal to 1. The observed rate law will be C. Navneet, very good. Okay, so fine. Chaliye. Next, we today start with a very interesting aspect of chemical kinetics, which is known as integrated rate law. If you know a bit of integration and a bit of mathematics regarding like equation of straight line, you should be able to do this very, very efficiently. Does not involve too much of mathematics. Integrated rate law helps us identify a number of things. It helps us identify an expression to calculate rate constant. It helps us to identify expression to calculate half-life. It helps us calculate an expression which gives us the time in which the total reaction will be over. We can draw certain graphs. We can write the expression of rate law in terms of x. So we can write it for any order reaction. We can write it for 0, first, nth, second, third. सबके लिए लिख सकते हैं. However, for JEE, as far as JEE is concerned, we will write it only for 0, first and nth. So today's class, we will try to write the integrated rate law for 0 order reaction. Okay? Clear? So let's discuss what is a 0 order reaction and how do we arrive at the rate law. Okay? So 0 order reaction will be written, a typical 0 order reaction will be written like this. A changes into products. A changes into products. And for this, the rate law will be written as rate is equal to rate constant A to the power 0. This will be the rate law for this reaction. Clear? This will be the rate law for this reaction. Now, moving ahead, can we say that initially its concentration was A? Okay? Initially, the concentration of A was A. Small a is the initial concentration. So let's say this is written as T equals to 0. Time equals to 0. Time 0 means initially. When I start the reaction, it is A. When the reaction starts, do we have any products? No. Clear? Do we have any products? No. When the reaction goes on for some time T, कुछ समय के बाद, after some time T, it will dissociate to an extent x and this will be x. Can I say this? Clear? So after some time t, A will become A minus x and some amount of products will be obtained. Now there is a very interesting aspect over here. Integrated rate law can be calculated with respect to the rate at which reactant is decomposing or with respect to the rate at which product is getting formed. Okay, so there are two ways to calculate integrated rate law. You can calculate integrated rate law using the rate at which A is getting decomposed or the rate at which product is getting formed. The easy thing to do is use products because you will get positive signs. If you use reactant, you will always have to work with a negative sign in the integral. But in products, what will be the rate of reaction when we take products? I will take it as equal to dx by dt. But over here, I will have to work with minus dx by dt. So the point is, do not use negative things in the equation because you might mess up a negative sign and your calculation goes wrong. Use products to calculate the expression. Okay, so can we write dx upon dt is equal to the k A minus x to the power 0. The rate obviously the rate at which the product gets formed is equal to k times the concentration of reactant. Okay, concentration of reactant raised to power 0. Clear? इसको हम ऐसे लिख देते हैं dx integral of dx is equal to k dt, integral of dx k dt. This will give me x which is equal to kt plus c. I'm not doing a definite integration, I'm doing indefinite integration. Okay, I'm not doing definite integration, I'm doing indefinite integration. How do we calculate for c? c कैसे निकालते हैं? For calculating c, can I say at t equals to 0, x was equal to 0? At t equal to 0 means at time equals to, at initially, when time was 0, x is equal to 0. So that makes, therefore, c is equal to 0. Okay, by putting t equal to 0, I'm getting c equal to 0. So our equation turns out to be this. Can I say that our equation turns out to be this? This equation will modify to form x is equal to kt. Okay, x is equal to kt. We will use this equation to calculate our relation of k and t and x. Okay, this is the relation that I have to use for zero order reaction. Clear? This is the expression that I will use for calculation of zero order reaction. The rate constant of zero order reaction, or how much amount of reactant is consumed after certain time t, or how much time it takes for consumption of a certain amount of reactant. Why only at? That is the way. Yeah, obviously. So equation of line के भी आप इसको use कर सकते हैं, बहुत simple सा है expression. So let's try to identify what other things we can infer. So what other things we can, so we start with the first expression. So x by t upon is equal to k. This is our first expression which we will give for, which we have inferred from integrated rate law. Second, time of completion. What is the time it will take for completion? When the reaction gets completed, the amount of reactant becomes 0 and the amount of product becomes equal to the amount of reactant. Can I say that? If the stoichiometric coefficient is 1 and 1, so if A changes into product, if this is A, this is 0, A minus X, this is X, this will become 0, this will become A. So at time, at completion, X will be equal to A, and this will be our time for completion. The time for completion will be this. Okay? Next, third. Half-life. What will be half-life? Half-life, the meaning of half-life is, I start with 10 moles, the time it takes for the reaction to consume 5 moles of it, or the time it takes for the initial concentration to reduce to 1/2 of it. Okay? So at half-life, what will happen? At half-life, A will become equal to A by 2. If at half-life, what will happen at T half, A will become, I will say A will become A by 2. Therefore, X will be equal to A by 2. X has to be equal to A by 2. So can I say for T half, if I incorporate the value of, this will be the half-life of zero order reaction. Okay, this will be the half-life for zero order reaction. It's way too simple, very easy expression. Okay? Clear? Clear? Now, what will be the ratio of T 75% and T 50%? Because you can be asked these ratios. What is the ratio of T 75% and T 50%? The meaning of 75% is that 75% of reactant is consumed. 75% of reactant is consumed. So A becomes A by 4, or X at this stage is 3A by 4, and 50% it is A by 2. Okay, 3A by 4, and this is A upon 2. So what is the time that it takes for 75% completion and 50% completion? I will divide both of them. For this I will write time as equal to 3A by 4K, and for this it will be written as A upon 2K. I will divide both of them. I will get 3 upon 2. Answer would be 3 upon 2. So you could be asked that T 50% is given and T 75% needs to be calculated. You could also be asked that T 50% is given, T 95% is to be calculated. So this is how you should be proceeding ahead. So 95%, if I do 95% of reaction, that means 95% of reactant is consumed. How much is left out? 5% of reaction is left out. Okay, clear? Fine. So please take a note of these inferences. You can derive these inferences on your own. It's very simple, very simple. Remember, while we have derived this, okay, now this is a pro tip for people who are preparing for advanced. When you are preparing for advanced, you have to work on the way the calculation is being done. For doing these calculations, what was the equation that we had considered? We had considered an equation like this: A changes to products. Okay, for doing these calculations, we had considered A changes to products. Clear? Now, what is the stoichiometric prefix for this? Prefix is 1. When the prefix is 1, I have calculated the answer like this. When the prefix is 1, I have calculated the answer like this. Now, if the question is given in this form, 2A changes to products, in that case, please do remember to incorporate this change. Please do remember to incorporate this change. When you are doing an integral, please do remember to incorporate this change. How would you incorporate this change? You will write A 0, A minus 2x, this will be x. Okay, you will write this thing as dx upon dt is equal to k dx upon dt is equal to k a minus 2x to the power n. Now always remember that it is given as 2a. When 2 is written over here, it does not create too big a difference. Okay, it does not create too big a difference. No, you will never be given in the general form, Preetham. You have to use your brains for that. However, so as long as there is a number given over here, 2a, 3a, 4a kind of a thing, in that case, the expression will not change a lot, but few inferences will change. Try to identify that. Okay, try to do that. We will take some questions on these changes in forthcoming classes, but try to work on that. Try to work on this as well. A changes to 3p. In that case, what will happen? Okay, A changes to 3p. In that case, what will happen? So when A changes to 3p, you will write this thing as 1 by 3 dx by dt is equal to k. In that case, you will have to put a 1 by 3 over here, because for product, the rate of using the product, the rate of reaction will become 1 by the stoichiometric coefficient times dx by dt. Okay, so remember that you have to use this small inferences or you have to keep a track of the reaction, whatever it is given. Unless and until it is mentioned, always consider the reaction with one stoichiometric coefficient. P will be 2x. No, P will not be 2x. Okay, Shantanu, P will not be 2x. Remember, the extent to which dissociation takes place depends on the stoichiometric coefficient ratio. Okay, stoichiometric coefficient ratio. So generally you are given a reaction where there is one reactant and one product. Don't worry about that. Okay, if there is more than one product, you can use any one of them to identify the answer. So with this, let's move ahead. Now if I try to calculate rate versus time plot, or if I want to draw the rate versus time, so rate of zero order reaction versus time, what will the plot look like? The plot will look like this. It will be a it will be a straight line parallel to the time axis. Okay, it will be a straight line parallel to the time axis. Clear? I don't have to explain this why it will be parallel to time axis, because rate is not changing with respect to time. Rate remains constant. Rate remains constant. If I take concentration versus time, concentration versus time, okay, so x is equal to kt. What is x? X is nothing but concentration. This exactly looks like y equals to mx kind of a, okay, so it's not parabola. Try and understand, not parabola. When you take concentration of reactant, whenever we draw it, by invariably we consider straight line passing through origin. No. For product it will be straight line passing through origin. For reactant अगर हम draw करें तो कैसा draw करेंगे? ऐसा. This will be for reactant. For product it will be like this. Okay. For product it will be like this. What will be the slope of this line? K. Slope, negative slope will be K, and this slope will be K. Okay, so this is for products and this is for reactants. Clear? I hope this is understood. बहुत simple है, कोई इसमें ज़्यादा load नहीं लेना होता है. Okay, so what is the summary for the zero order reaction? The concentration of reactant decreases linearly with time, and if I look at the change, concentration of reactant at time t is equal to reactant concentration at time 0 minus kt. It will be an equation of a straight line. इसी तरह का दिखेगा. A zero order reaction goes for completion when the initial A naught means initial concentration, A naught by K. We had written A by K, they have written A naught by K. A naught means A, initial concentration. The rate of zero order reaction remains constant and does not change with respect to time. Half-life period is dependent on the initial concentration. If the initial concentration is increased, the half-life time will also increase. The unit is moles per liter per second. Okay. Also, for zero order reaction, I cannot define molecularity because molecularity cannot be zero. So for a zero order reactions are complex. Zero order reactions are complex. So they will always be comprised of more than one step. Okay. Zero order reaction will always have more than one step. Now I'm giving you a homework, and the question is this. Okay. The question is this. Let's take a reaction which is given in the form A changes to 3B. A zero order reaction is given which is A changes to 3B. Okay. I'm drawing concentration versus time plot, and when we draw concentration versus time plot, I observe a plot like this. Okay, This point of intersection is obtained at time which is 20 seconds. Okay, this point of intersection is obtained at a time which is equal to 20 seconds. This is for reactant, this is for product. You have to calculate what is the T half for reaction. For this reaction, what is the T half for reaction? Yeah, Pratham, NCRT is enough. NCRT plus exemplar series solve all the problems. It should be enough for 12th. Okay, enough for 12th. So reaction is A changes to 3B. Its reaction is not A is equal to B. Reaction is A changes to 3B. The point of intersection is obtained at 20 seconds. You have to calculate what is the T half. This is your homework. Okay, we will take this question in the next class. Okay, we'll take this question in the next class, and it's mains ले लो या advanced ले लो, किसी भी एक level का question है. And remember how when you form an equation to solve this question, you will be able to understand that how do you incorporate the small changes if there are small prefixes given for zero order reaction. Okay, so is it enough for IIT? Yeah, IIT के लिए enough है यार, इतना ही concept चाहिए. Okay, इतनी ही concept चाहिए. So with this, I end today's session, and I hope you have taken a note of this question. Try to solve this question again, and in today's 6 p.m. Pulkit sir will be taking classes on integration periodic functions, and there's a JEE pre-RMO class scheduled at 7, KVPY thermodynamics, chemical and ionic equilibrium, that is for SA stream, and electrostats for I guess SX stream. Okay, so we'll continue from here. Today we have limited the session to zero order reaction. Next session will be on first order reaction. Okay, so please do join. Please do join us the next time. That's on Friday for the first order reaction, and we'll continue. एक बार पढ़ के आओ तो easy हो जाएगा उसको. ठीक है? So bye bye guys and have a lovely time.